This is College Physics Answers with Sean Ditchko. The relative humidity at temperature 1, which is 30 degrees Celsius, is 80%. And we're asked to find out what is the relative humidity going to be at temperature 2, 25 degrees Celsius, assuming the same vapor density. So we have to figure out what the vapor density is. And so at temperature 1, we have relative humidity number 1 is the vapor density divided by the saturation vapor density times 100%. And so we'll multiply both sides by the saturation vapor density at 30 degrees Celsius. And then divide both sides by 100%. And we get the vapor density then is the relative humidity multiplied by the saturation vapor density at 30 degrees divided by 100%. So that's 80% divided by 100% times the saturation vapor density that we look up in table 13.5. So at 30 degrees Celsius, we have a saturation vapor density in grams per cubic meter of 30.4. So we plug that number in here, and we get the vapor density is 24.32 grams per cubic meter. Now at temperature 2, which is 25 degrees Celsius, the relative humidity then will be that same vapor density, we assume, divided by the saturation vapor density at 25 degrees Celsius times 100%. So we have 24.32 grams per cubic meter divided by 23.0 grams per cubic meter, since that's the saturation vapor density at 25 degrees Celsius, times 100%, which is 106%. So that's unreasonable because the maximum relative humidity is 100%. And so what's really going to happen is as the temperature decreases from 30 to 25 degrees Celsius, rain would occur, and that would reduce the vapor density and keep relative humidity at a maximum of 100%. So the assumption that vapor density is constant is false.